Our mission is so it should be fairly clear by now that I believe that solar-powered synthetic fuels are inevitable. They are the way that humanity will make its carbon-based chemicals in the future, right? So if you jumped in a time machine and came down 500 years' time, the world would be very different, but I'm 100% sure that we'll be making most of our chemicals from solar synthetics. So the question that you have to ask is, how long does it take us to get there? What can we do to accelerate that? How can we liberate value and make money and scale while we do that?
Hardware to Save a Planet explores the technical innovations that are giving us hope in the fight against climate change. Each episode focuses on a specific climate challenge and explores an emerging physical technology solution with the person bringing it into reality. I'm your host, Dylan Gary. Hardware to Save a Planet is brought to you by Synapse. Make sure to click subscribe so you don't miss any future episodes. Thanks for listening. Hello and welcome to Hardware to Save a Planet. This episode continues my conversation with Casey Handmer, founder of Terraform Industries, a company that has the goal to produce cheap natural gas with sunlight and air. In part one, we discussed Casey's background, including his PhD from Caltech and experience at NASA, bridging his interest in space and climate tech. Casey outlined Terraform's mission, emphasizing the potential for cheap solar energy to enable direct air capture and the production of green hydrogen, which can then be converted into methane through methanation. Casey highlighted the importance of creating a scalable business model centered around carbon capture and sustainable energy production. We discussed humanity's dependence on hydrocarbons for so much, including transportation, heating, and the production of fertilizers and plastics. And while there is a trend towards electrification in certain sectors, completely transitioning away from hydrocarbons may not be as realistic as some might hope. I'm excited by what Casey and his team at Terraform are aiming to achieve, and I hope you enjoy the rest of our conversation. If I understand it right, you're optimizing for something different. Those systems are optimized, at least on the hydrogen electrolysis side, electrolyzers. They're optimizing for energy efficiency, which means they are more expensive, which means they have to be long-term reliable to be able to amortize their costs over their lifetime of operation. And actually, you've sort of flipped that on its head and said, you're going to optimize for low capex and not optimize for energy efficiency because energy in the form of solar produced on site is so cheap.
You're right.
Decent summary?
Yeah. So like why build all these things in-house versus go out and buy them? It's true that there are a number of companies that are like trying valiantly to produce cheaper green hydrogen or cheaper CO2 via direct air capture. Because they're not unable to do kind of the vertical integration, they end up having to add features for customers that we don't need, that add costs that we don't want. And I would also say that like these markets are a lot less mature and a lot less efficient than you might assume. So like when I started this, I thought, well, I might be able to buy the electrolyzer, but direct to capture I'm on my own, and methanation reactor. Yeah, there's a handful of companies that'll build them for you, but like you basically be paying them to do all the non-recurring engineering cost and then developing all that expertise for them. And then at the end of the day, what have you got for it? Well, you want to do it again, you got to do it again. Whereas if you in-house it all, you get to have total control over the technical trades you're making. You get to have total control over all the unnecessary features that you can strip out to save value. When you integrate the final product, you don't have to split your margin with subcontractors and other customers. And I think that's super important. It's very, very underrated that if you're in a commodity business, you want to own the whole vertical because there's just not enough fat in the margins to kind of share it between 6 different layers of subcontractors. There are other industries where that's not the case, right? And it makes sense to have subcontractors like specializing or whatever. But in this case, I think that you really want to do the whole thing yourself, which is what we're doing. And in retrospect, I'm glad that we did. I think if I'd set out 3 years ago and assumed that by 2024 I'll be able to buy a $100 kilowatt electrolyzer off the shelf, in arbitrarily high volumes, it does what we needed to do on the tin. Well, it hasn't turned out that way, has it? So we would have been in deep trouble if that was the case. I assumed that in the United States we'd have significant progress on solar installation cost. In other words, that we would see a significant cost pressure on the balance of plant's costs on solar farms, because until quite recently the panels were by far the dominant cost, and so the rest didn't really matter that much. But it's not the case anymore. And now like everything else costs much more than the panels. And I thought, well, these things are coming under cost pressure for the first time. They'll probably find ways of saving money there. In general, that has actually not been the case. And the reason for that is that it turns out that the constraint on deployment is not price. It's grid interconnection capacity for on-grid solar deployment. And so if you're a developer in that space right now, you're kind of like, a bunch of companies fighting over ever diminishing slice of pie because the grid is not growing. And so in order to stay in business, they've had to find ways to add cost, to their product in kind of much the same way that the nuclear industry did in the 70s, with obviously horrible outcomes for them. Fortunately, unlike the nuclear industry, the barrier to entry on solar installation is basically non-existent. So we are just in-housing that capability ourselves, and we're going to verticalize across all the installation as well, which in the short term is slightly painful, but actually it's in terms of its pain, it's a nice vacation from the usual pain we have to deal with. And in the long term, will be hugely advantageous because it means that we'll be able to just be a single point of contact for our developer customers to deal with. They won't have to coordinate with multiple other teams. We'll basically own everything from the surface of the sun to their delivered gas. Will be something that we just sell as a single combined unit.
Just to complete the picture, can you describe quickly what your direct air capture process is?
So basically the same problem applies here, which is like I need to be able to capture CO2. And instead of it being a cost center where like we set up a business along the lines of like sooner or later someone will cut us $1 trillion check, to we want to capture CO2 cheaply enough that it becomes the default source of carbon in our economy, which is a problem because CO2 has oxygen on it, and oxygen is like very energetically expensive to remove from carbon. So as a source of carbon, it's not great. Right, so like if you want to make charcoal, you can start with wood, and it takes a certain amount of energy to like strip the water out of it and make it into pure carbon. But if you want to make charcoal, it's much easier to make charcoal out of wood than to make it out of CO2. That's for sure. Obviously, because once you burn it, that's where it goes. But fortunately, energy is cheap, so you got to find some way to like solve these problems where you say, well, I'm prepared to sacrifice a bit of electrical efficiency, but mostly I just have to like cram down capex like crazy. And then focus on systems that I can mass produce at extremely high volumes. So there's many, many, many ways, maybe 100 different ways of capturing CO2 from the air. But in general, we're using a method called a chemical sorbent. So you want to pick some kind of chemical that like absorbs CO2 from the air and then releases it under different phases. And again, conventional wisdom in the space has said, well, it's quite energetically difficult to absorb and release CO2. So we want to try and focus our efforts on finding extremely high efficiency chemicals that do this very quickly. Or very easily. There's a wonderful area of chemistry called metal organic frameworks, where there's like tens of thousands of different compounds you can make. And a little bit like condensed matter physics is kind of really quite wild, like physics that you can generate making different MOFs. And so basically for any application you can imagine, you'd be like, I bet there's a MOF that'll solve that. Like just, you can get extremely close to the, what's called like the theoretic like enthalpy limit on separating CO2 from air, which is ludicrously low, because just like dissolving pure CO2 in air does not like release very much energy. So in principle, you can reverse that extremely cheaply. And that's a super cool trick, right? And I actually worked on MOFs many, many years ago. And I just think it's fascinating chemistry. But the question you have to ask is this useful for business? And you say, well, how much do the MOFs cost? And they're like, well, currently they cost $50,000 a gram. But if we get really good at manufacturing them, we might be able to pull that down to like $5,000 a gram. And then you run the math on, okay, well, I want to capture 50 billion tons of CO2 a year. And my cycle time is going to be like, let's say a day for my sorbent beds. So I'll get to reuse my sorbent 365 times a year. And then most of these sorbents, if you're lucky, a gram of sorbent will absorb a gram of CO2 or maybe a tenth of a gram of CO2 or something like that. And so you start running the math and you start realizing that you're going to need at least hundreds of millions of tons of sorbent. So what's 100 million tons times $50,000 a gram is like significantly more than the cumulative GDP of the entire world since like the beginning of time. So I would like to think that if it was the case that humanity and the entire world would cease to exist unless we solved this problem, we could figure out some way of solving this problem. I think that it's certainly within the realm of like the laws of physics that you could solve this problem. But also as a small technical startup, do I want to put solving this problem on my critical path? No, I do not. So instead, let's look at the other end of the spectrum at like the cheapest possible CO2 solvent and see how it operates. And it turns out that calcium hydroxide is just an absolute fiend for CO2. It loves it, which is why ocean animals use calcium hydroxide. They literally make calcium hydroxide in their cell walls to absorb CO2 from the air to form calcium carbonate, which is a really strong mineral and a really good thing to make your shell out of if you're a sea animal or a coral or something like that. And they do that in preference to generally, and there's exceptions of course in biology, but they do that in preference to all the other methods for fixing CO2 and all the other kind of CO2 mineralization projects. So you use calcium hydroxide, absorb CO2 really, really well. The flip side of that is that it takes a lot of energy to release the CO2. So whereas sodium bicarbonate, which is sodium hydrogen carbonate, you can put that in the oven, and at like the temperature you bake a cake, it releases CO2 and makes your cake nice and fluffy. And the leftover sodium will hopefully kind of become a bit of salt that improves the taste, but also adds kind of a soapy flavor if you put too much in. because it makes it a bit alkaline. Calcium carbonate requires about 900 degrees Celsius to separate, and that's actually the process we use to make Portland cement, of which humanity makes 5 billion tons a year. That's like almost a ton per person, which is kind of nuts. So humanity makes about 5 billion tons of cement a year. With this process, it's called calcination. You heat the calcium carbonate up to about 900 Celsius, and the CO2 comes off, and you're left over with calcium oxide. You mix the calcium oxide with water to regenerate calcium hydroxide, and you're good to go. You just keep on recycling this sorbent round and round and round. And unlike amines or zeolites, which are other chemicals you can use to absorb CO2, it's extremely robust chemistry. It's really, really hard to break down the sorbent or mess it up in some way. So again, the nice thing is you're solving that problem with high temperature. Well, high temperature is just energy. Energy is cheap from solar panels, which build a cheap electric kiln, and problem solved. So yeah, it's just like a typically brutal, straightforward, do the obvious thing, do it well approach to doing character capture. There are many other ways of doing
CapEx.
it. I don't want to say for sure that this is the best, but yeah, our CapEx goal for director capture is $100 per ton year, and then the OpEx cost on top is $100 a ton. I think long term we'll get down about a factor of 2 below that, but right now we're pretty close to those numbers, which is where I want to be. And at that cost, we can make money. At that cost, CO2 becomes a profit center rather than a cost center, which is super important. I think the importance of this is massively underestimated. Yeah, that's the now your listeners know how to do this. If you'd like to compete, let me know, and I'll help you organize some seed funding. I would love some worthy competition, but you have to have a certain amount of masochism to try and do this sort of stuff. So
I guess relating that to your specific approach, I imagine because you've kind of chosen this low capex, relatively simple architecture relative to the approach other people are taking, your speed of kind of iteration as you're maturing your technology must be faster. You're able to iterate your prototypes and test. Yeah.
I think in general, you want to have the fastest feedback loops you possibly can, and you want to iterate and improve. And kind of one way of thinking about that is if you achieve 1% improvement every day, you will far exceed 100% improvement every 6 months or something like that, right? It's like the cumulative effect of lots of really rapid minor improvements is much, much larger. Yeah, and in our case with hardware, anyone on our team could figure out how to build a Terraformer for $10 million, right? It's not, and it would be guaranteed to work. The challenge is figuring out how to make it work with less. There's a process thing that's called mutzing or lutzing or something where you take your circuit board that works and you just start cutting components off it until it stops working. It turns out that a lot of the parts you thought you needed are actually, they're not contributing. They're not paying their way, if that makes any sense. They're not actually adding value, and it still works just fine without them. We basically just have to continue to do it. That's a very experimental process to figure out, how many corners we can cut and still have a system that works safely. But in the process, we're learning things about building extremely low capex, solar adapted, materials processing technology that I think will basically form the basis of the next. Well, certainly the growth of the secondary industry layer of our economy for probably for the rest of forever. But at least there's gonna be pretty extraordinary growth in solar over the next 20 years. Yeah, solar applications in particular. So yeah, we're kind of I'd say one of the world experts at that at this point, and we're not slowing down. The other major area for growth, of course, is AI, but that's much more tertiary, I think, much more kind of consumer and knowledge worker focused.
The other topic I wanted to hit is kind of the business model side of it, and maybe to start there, this is all dependent on on cheap solar. And I was curious, I know we've come way down the cost curve on solar. Is it already cheap enough to make this a viable business, or are you counting on further
for sure.
kind of cost reductions?
Yeah, so 3 years ago, I thought solar would almost certainly be in the right range for us by 2029, and it already is now. So let that be a lesson to you. Of course, it would help us if it got cheaper still, but we can make it work right now.
And it will keep getting cheaper.
Well, I mean, it's important to ask the question, why will it keep getting cheaper? And kind of right off the bat, you can say, well, the next couple of years are going to get cheaper because we've already locked in the further ongoing investment in production and so on. And there is a bit of a solar glut, and we're seeing panels change hands for as low as 6 cents a watt right now, which is mind blowing, absolutely incredible. Solar panels went from being cheaper than drywall to cheaper than any other material. People are literally siding their houses with them, which is a pretty cool trick. And so that's that's kind of the nearsighted projection. Then you say, well, long term, how cheap could they get? And you can start from like kind of first principles and say, well, what is solar panel, and just how much material do you need to build a solar panel, and what is the kind of the minimum cost to build that solar panel? And it turns out that like most of these things, it's kind of a two-dimensional system. So the amount of material you need is very, very small, and you can most of the cost in processing it is energy cost. And so if you're self-feeding your own energy at that point, you can kind of continue to push that down. And then you need to say, okay, so it's physically possible to build an extremely cheap solar panel, but is there an economic imperative to do it? And then I think it's a slightly more complicated question, but basically the question you have to ask yourself is, per month of cost improvement, do you get a commensurate demand increase that justifies the next month of cost improvement? And that's not always the case. In some industries, sooner or later, you will saturate demand, and there'll be no further impetus to cut costs any further. In solar, it is extremely clear this is not the case. In solar, it is extremely clear that if anything, the value is accelerating. Like the value, this should seem obvious there. Like we figured out how to manufacture energy. We figured out how to run a factory where an output is energy rather than an input being energy. That over time, the solar cost will continue to fall by like 15% per year. Demand will continue to increase by about 50% per year, and the learning rate on solar is about 43% per doubling of production. So the cost reductions will outstrip demand satiation until you reach whatever the physical limit is, which might well be like the surface area of the Earth, something like that.
You mentioned the IRA a little bit. I think it's 45V is the hydrogen tax credit. I think there's 45Q is the for direct air capture of CO2. To what extent is that an important kind of component of your business model? And as we're sitting here in election week here, we just finished our election in the US. I'm curious how much how do you anticipate that impacting your business at all, if at all?
Yeah, I mean, it would not surprise me all that much if Trump or one of his cabinet members decides to take a swing at the IRA, and in particular at the kind of more climate-focused aspects of it. And I think in retrospect, there are certainly parts of it that I would be happy to delete. I won't be too specific there, but one of the major failures of the Biden administration was that they successfully got a whole bunch of very important legislation across the line for like rapidly building and expanding infrastructure and so on. And then at the last minute, they added a whole bunch of additional marginal requirements to it that did not really hinge on the success of that project. And because it was functionally impossible to satisfy those requirements, the money didn't get spent. And now it's too late, and no one benefited from it, right? Like, because just to kind of gratify some tiny constituency, they kind of added some wording to, I don't know, like the electric charger rollout program, where they allocated $42 billion or something to this program. They didn't spend it all. They spent hardly any of it. But they didn't build any electric chargers. They got no electric chargers. And then everyone just makes a mockery of the program. Too many cooks in the kitchen. And so there's certainly some stuff there that I think could be deleted to make the program itself much more effective. And then as far as 45V goes, it was, in my view, it's always kind of been too good to be true. So I've never planned here on it being a sure thing for any length of time, let alone forever. As currently written, we'd still be extracting 45V subsidies in 2048, at which point it would be worth more than $1 trillion per year, which I just don't think is going to happen. Even if Trump and his congressional allies don't rip that out, I think that sooner or later, all those subsidies have to go away, because otherwise you're not actually delivering value, right? Like you're effectively just transferring fuel costs to the taxpayer as opposed to like payment at the point of use. Yeah, so that's always been part of our plan as a kind of outline. If you can make green hydrogen for $1 a kilogram, you can make gasoline for $4 a gallon. If you make gasoline for $4 a gallon, you're in business in most of the world, right? And as long as you are able to decrease your costs the same way solar is, like decrease your costs faster than your saturating demand at that new lower price point, then you're going to win. And it's very, very clear to me that we don't even have to trial that hard on cost reduction, because the size of the market is so enormous that we have to do about 8 or 9 orders of magnitude in terms of production expansion to saturate it, that we're going to be okay there. So I'm actually relatively sanguine about it. I think all things considered, 45V will help to accelerate us and other similar businesses. But also, like, a lot of the conversation around 45V has been dominated by legacy hydrogen projects that are actually not even eligible under the Treasury's draft guidance, which of course took 3 years to highly efficiently produce. Because that's sarcasm, by the way. Because basically Treasury came out and said, well, this is a huge windfall. We're not going to hand it out for projects that are not additional and not time matching. Cue the whinges from the usual suspects. Because in my view, it makes sense, right? If taxpayers are going to pay $3 a kilo for green hydrogen, which is objectively kind of a bad deal in terms of energy, but maybe a good deal in terms of like long-term energy development or something, that it better damn well be additional, right? Something that wouldn't have been built otherwise, and it better damn well be time matching, something that's actually using green energy. But the problem is, if you're building some conventional like 1 gigawatt green hydrogen development project and it's off on the grid, then you're using legacy generating infrastructure on the grid. Well, that's not additional. And if you're powering it at nighttime, well, where are you getting the power from? But I do think that if we're going to be spending public money massively subsidizing these projects, then it better damn well actually be a good deal. And it's just to kind of give you a concrete example there. There's kind of a parallel industry to this one, which we haven't talked about yet, which is the sustainable aviation fuel industry. And the idea there is that aviation is incredibly energy intensive, right? So I'm Australian and I fly home to Australia once in a while. And when I fly home to Australia, the per seat fuel allocation is on the order of 1,000 liters. It's like a waterbed full of fuel per person just to get across the Pacific and back, which is an astonishing amount of fuel, right? Like I could drive a Hummer all year and it would make no difference if I fly to Australia twice a year. So the people who are concerned about carbon footprint, which is to say carbon consumption per person, not normalized by GDP or anything, I say, well, this is a horrible thing. We need to solve this problem. The way we're going to do it is we're going to force airlines to force their customers to pay extra. Well, all that does is it makes aviation more exclusive, right? It just makes it less accessible to people. And what are they paying extra for? They're paying either for some dodgy carbon offset, or they're being forced to buy SAF, which is like 5 or 6 times the price as regular aviation fuel, which is already pretty expensive. Is that a good deal, right? Like that's just increasing the cost of aviation, which you have to pass on to customers. Okay, well, on top of that, SAF is also derived from, generally speaking, until we get into this business, SAF is typically derived from agricultural waste products or forestry waste products, right? Which means that it's fundamentally limited, right? There's just not that much of it. So in terms of like the total global demand for SAF or for aviation fuel versus what you could plausibly produce by recycling every bit of farm waste in the entire world is like 1%, right? So like you could do all this effort and you're not going to move the needle on carbon emissions. And then if you look under the hood and you say, okay, well, so what is the process to convert a bunch of farm waste into sustainable aviation fuel? I bet it's really good for the environment, right? No, it's not. It's terrible, right? It actually, it consumes a huge amount of fresh water. It produces a bunch of waste products that are difficult to dispose of and environmentally toxic. And it also produces a whole bunch of fugitive methane, which, technically it's possible to capture, but in practice mostly gets away. And that methane has a 40 or 50 times higher carbon, climate forcing factor per unit molecule than CO2 does. So you're literally better off like flaring that methane, at the point where it's generated if the concentrations are high enough to burn. And even then, like building an efficient methane flare is really hard. Like building a methane flare that actually burns most of the gas is really hard. And so you're like, okay, what a deal. We're going to put all this time and effort into making a sustainable aviation fuel, which we're going to force down our customers and our businesses' throats within our own thing, decreasing their privileges, decreasing their wealth, and decreasing their economic competitiveness, right? Oh, and by the way, it can't solve the climate problem, and it's also really expensive, and it's also worse for the environment than just drilling a hole in the ground, getting kerosene out and burning it. This is crazy. And like, so you asked me, how much should like the Inflation Reduction Act, for example, pay to subsidize this industry? My answer is zero. It should not get subsidies. It should be forced to compete, right? It should actually compete on its own merits, or like it should be forced to show that it's not subject to these problems. That's kind of how I feel about it. So generally speaking, my expectation is that the 45Q, for example, which has been around forever, that'll stay there because that was put there was kind of put in there to gratify oil production in Oklahoma that captures and reuses and reinjects CO2 underground to enhance oil production. So like that's going to stay there. That's basically a handout to industry. But at the same time, I think that I think there's both a social and a strategic good to have copious supply of hydrocarbons within your own borders at affordable prices. Speaking of like progressive and like humanistic goals, cheap fuel is one of them. Cheap fuel is really the most important one. And as far as 45V goes, I mean, it's a very cheap subsidy right now because no one's able to claim it. So hopefully it escapes notice on that front. And there's a few others that I think could probably be improved along the way, but we'll see. The thing is like, is there a massive constituency that's going to actually have like leverage to get that, to like keep that there or not? It's not something that's going to keep your business upright forever. It's the sort of thing you have to spend to gain the confidence you need to push the price down into real territory straight as quickly as you possibly can. And I think Tesla followed that same route, right? They started off with the Tesla Roadster that was a very expensive car that was kind of, they only produced a few thousand of them, and no one could really tell you like, oh, this car's good value for money, right? It's just a fun toy. But they turned that money around, that expertise around. They built the Model S, Model X, and Model 3, Model Y, and the Model 3 and Model Y are terrific value cars. They're competitive without subsidies in essentially every market on earth, and as they should be, right?
How do the incumbent players in the hydrocarbon industry look at you? I'm thinking like the Chevrons and Exxon Mobil's and Saudi Aramco. Like, what Are you a competitor?
That's an interesting question.
Or-
No, not really. So my initial thought was like, oh, I'm sure when I go to Texas, I'm going to get a warm welcome, sarcasm, from all the oil drillers. They'll just be thrilled to have some foreigner, crunchy West Coast liberal telling them how to do their jobs. But actually, what we found was that they were super receptive to it, and they've been thinking about this a lot themselves. They know as well as anyone does that oil drilling is a tough business with slim margins, and it's getting worse, right? Because we're running out of the stuff. And at the same time, many of them already have experience in energy development for solar and for wind. And so the idea that you can actually build like a positive net present value system to basically like power their legacy business from like their growing business, like the solar deployment's growing business and oil drilling's legacy business, and keep some value on the books for all their legacy infrastructure and refineries and pipelines and so on. It's music to their ears, right? We've literally never had anyone in this industry say, that's ridiculous, you're crazy, get out of my hair, what would you know about it? They're like, positive unit economics, now you're speaking my language. The ones who know their way around a chemical plant are like, wow, that's really ambitious, as well they should, right? Or like, wow, you're going to take, we usually burn gas to make electricity. You're going to take electricity and turn it back into gas. Like, that's going to be tough. And they're not wrong, right? Like we kind of talked about how that works. And actually in contrast, like the major obstacles to our deployment, largely like over-enforced environmental protection regulations here in California under CEQA and NEPA, which, they were kind of put in place about 50 years ago. And I think justifiably then to safeguard kind of human health and environmental health in the face of kind of overwhelming development in the post-war period. It's kind of unfortunate they arrived at the same time that oil prices got uncertain, because then they ended up contributing to kind of the intervening 50 years of economic malaise that we've seen worldwide, where kind of growth has not been at its historical levels. But nowadays we're in the situation where like, if I could put a gigawatt of solar down, I'm going to save thousands of American lives from the impact of like coal-fired power plant air pollution. Like literally 9/11's worth of people every few months are dying unnecessarily in the United States from air pollution caused by legacy power plants that are already unable to compete with solar, or wind for that matter, except that I can't put solar in the ground because NEPA, an environmental protection law, makes it hard. Like this is absolutely mind-blowing. And again, like I'm optimistic or hopeful that this law will be updated. I mean, like Nixon put it through, and I'm hoping that this law will be updated to recognize the fact that actually doing nothing is a choice, and doing nothing has costs as well, right? So like doing nothing and just continuing to burn coal has like 100 times higher environmental and human health impact than installing solar does. And that actually the environmental impact of solar is both extremely low and very easy to reverse, as opposed to, say, the environmental impact of doing a coal fly ash disposal pond or something, which effectively poisons that land forever, is impossible to remediate, or coal mine or something like that. Like putting solar panels out in the ground has, as I said before, much lower impact than farming. And unlike farming, you can fallow a farm, but you won't recover the pre-existing subsoil biota and plants and animals, and even desert areas anytime soon. Whereas with solar, you could literally just pick the panels up off the ground and it would be essentially the same as it was before, with a bit of rusting steel left in the ground. Which seems, it's crazy to me that to develop these projects at large scale in California requires a 4-year environmental review, with a 15,000 environmental impact statement prepared by your expensive consultants to avoid lawsuits and get a finding of no significant impact. It's completely upside down. It's completely crazy. And I think a lot of people understand this now, and we're well on the way to rationalizing this policy and accelerating the rate at which we are deploying solar. China understands this. China, not exactly a paragon of like environmental protection, put down 160 gigawatts in the last 9 months. They understand what's going on, right? And the United States has always done well by being the place where energy is cheapest, but I'm deeply concerned that will not be the case forever if we don't get our act together on this front.
What's the future of Terraform Industries? Can you quantify the impact you want to have?
Statistically speaking, most startups fail, especially most hardware startups by first-time founders in unproven industries doing technology that some experts regard as impossible. So we have our eyes open about that, right? Like success is not guaranteed. That said, the odds of failure have been diminishing steadily and monotonically, to reassure our investors. Since the very beginning, we kind of stack ranked all our major risks at the very beginning. We internalized as many of them as we could, so we can control them, and then we burn them down one by one. And at this point, barring a major crisis, like we're going to make it. What is our impact? Our mission is so it should be fairly clear by now that I believe that solar-powered synthetic fuels are inevitable. They are the way that humanity will make its carbon-based chemicals in the future, right? So if you jumped in a time machine and came down 500 years' time, the world will be very different, but I'm 100% sure that we'll be making most of our chemicals from solar synthetics. So the question that you have to ask is, how long does it take us to get there? What can we do to accelerate that? How can we liberate value and make money and scale while we do that, right? How can we by taking this objectively awesome future and bringing it to now quicker. How do we unlock the value of doing that to enable us to accelerate, like to power our engine of innovation and deployment? And that's really the $1 million question. Or let's say the $1 trillion question, actually. The size of this industry is measured in trillions of dollars. So we've been speaking for an hour and a half, and in that time, the global oil and gas industry has turned over $1.5 billion. I can just see this like raging torrent of gold just outside my reach. So what is our impact? Our impact is to help catalyze this transformation. So we'll just do it ourselves. We'll do it ourselves until competitors join in, right? And then we'll coordinate with them and work with them. But this industry is easily large enough that you could have a few hundred multi-billion-dollar companies in every major city on earth all doing this, and yet crickets. There's nothing going on. There's like one other company I know of that's in UK that's following our lead. They're doing great, but like it's a very, very sparse thing. I think that it'll be one of those things where it happens slowly at first and all at once. So I like to demarcate the transition into 4 separate phases. And the first phase is like kind of incipient exponential growth, and we're in that phase right now. So like it is clear to us that the markets where we are able to make money are expanding at an exponential rate because solar cost is continuing to increase. The fraction of the world's population that lives in places where we would work, where like our technology would work and be making money today is growing very quickly. So after about probably 6 to 8 years or so of like flat out deployment, so we're talking like early 2030s, we'll be serving on the order of high hundreds of millions to billion customers worldwide. So we're saying like large scale deployment in North America, Europe, and East Asia, and the subcontinent most likely. And then after that, it's basically the growth rate slows down, but growth is still continuing. And that's like consolidation, probably not building many more factories, but just increasing production of existing factories. And then once you reach the halfway point, 4 billion people from then, it's kind of diminishing demand on the other side of that, although the systems themselves don't last forever. So you have to continually like backfill and rebuild existing infrastructure that you've already built. But by that point, the capacity is much larger, so you can do that quite easily. And you probably, so I said like 6 to 8 years for the first quarter, probably another 6 years or so to halfway, and then probably another 10 years or so after that to basically push the remaining oil drilling and gas drilling, coal mining, and so on out of the marketplace, where you kind of go from a place where like you are just about competitive with new development to where you are competitive with existing systems that are like already fully paid off. So initially you have to fight against both CapEx and OpEx, and then later on you'd only fight against OpEx. And like it's already the point right now, for example, where new build solar is cheaper energy than old coal, where you're just paying for the coal. And we'll get to that point. And I think if we do it well, it'll be all over by about 2042. So I'll be in my mid-50s and looking for the next project by then. Hopefully I'll still be around.
This has been a really fascinating conversation. I would love to keep going. You have some world saving to do though, so I should let you go. I do want to wrap up with 3 questions that I ask everybody at the end of each episode.
Yeah, sure.
And these can be quick answers. The first is, how optimistic or pessimistic are you about the future of the planet, and why?
I'm very optimistic. I mean, as a technologist, I'm a sort of person who sees every problem with like a giant hammer in hand. But I think our ability to like actually do something about our problems has never been greater than it is today. It's conspicuously obvious, actually. And it's actually a very short list of like major problems that remain for humanity. We've pretty much solved hunger. We've solved disease. In many places, we've solved energy scarcity in useful ways. Kind of, there's only really a small handful of kind of the horsemen of the apocalypse that are left to crush. I'm very optimistic that we're going to do it in our generation.
I love it, and I can definitely sense that. Who is another company or individual doing something to address climate change now that is inspiring you?
Oh yeah, a shout out to my friends at Make Sunsets. So this is Luke and Andrew. They have this little startup. They're extremely scrappy. They were actually just featured on S3 recently, so you can check them out there. Yeah, they're doing sulfur injection into the stratosphere, which is by far the highest leverage system we have for avoiding catastrophic impacts of climate change in the next 10 or 20 years while we kind of get the supply chain retrofit in place, which is what we're working on here. It is my opinion that every time we see a hurricane devastate a coastal area or another glacier slide into the ocean, that is a mostly irreversible negative impact that is entirely voluntary. Like we are literally accepting this for no reason, and the cost to avoid it is tiny in comparison, absolutely minuscule in comparison. And literally just because some of our institutions have some inertia, we're not doing enough to solve this problem. And Andrew and Luke are fighting the good fight against that. And I'm proud to have been a supporter of them since the very early days, and I will continue to. there's kind of a three-step process that's necessary to solve the climate problem. And step one is don't let it get any worse in the meantime, which is what sulfur is for. Step two is retrofit the oil and gas supply chain, and step three is soak up about 1 trillion tons of legacy CO2. All three of these processes are geoengineering. They're like mega scale projects. Only really one of them can pay for itself organically, but the other one is sulfur is very, very cheap, and then CO2 capture at scale, or CO2 sequestration at scale is cheap compared to the alternative. So I think very, very optimistic about them.
What advice do you have for someone who's not working in climate today but wants to do something to help?
Well, there's many valuable areas to work on other than climate. So if you want to work on climate, well, the world's your oyster. I would say it's such a huge problem that you have to aggressively seek out high leverage opportunities, right? Things where you in person can have a huge impact. And that almost always involves some form of technology. And it's not really enough to turn the lights off or dim the lights or turn down the thermostat or something. It's not making a difference. Even if it would make a difference at scale, it's still not the sort of future that we want. The answer is not to regress our technology and live as Stone Age primitives. Yeah, the answer is to emancipate ourselves fully. We're most of the way there. We just have to keep going. And then the other major thing where I think there's a major misallocation of capital is actually in longevity research. So it seems blindingly obvious to me that the cost of our kind of inverted demographic pyramid, aging and dying continually, is measured in the at least hundreds of billions, if not trillions of dollars per year. And yet the amount of money that we spend on researching medicines and technologies that can slow down the rate of aging it's not even 100,000th of that. Right. So what the hell are we doing? This seems crazy. And I think that we need more people with different points of view to jump into that problem and have a good crack at it. So if you're more biologically inclined, feel free to solve immortality, and I'll thank you. If we don't figure out immortality, we're all going to die.
Casey, this has been really fun. Yeah, I really appreciate your time. I've learned a lot. I'm impressed by what you're doing. Thank you so much. Hardware to Save a Planet is brought to you by Synapse. To find out more about us and how we develop hardware solutions for the world's most ambitious companies, head to synapse.com. And then make sure to search for Hardware to Save a Planet in Apple Podcasts, Spotify, and Google Podcasts, or anywhere you like to listen. Make sure to click subscribe so you don't miss any future episodes. On behalf of the team here at Synapse, thanks for listening.